The average rate of change is a calculation that becomes increasingly important as you transition from your study of algebra to your study of pre-calculus and calculus. Because of our work with quadratic equations, it makes sense to take a quick look at average rate of change, familiarize ourselves with the format of the function, or the format of the calculation, and what does it tell us about a particular function. So here we have the function f of x equals 16 minus x squared. When we calculate the average rate of change, we are calculating the change in the function over how long it took for that change to take place. So from f of 3 to f of 0, how much did the value of the function change over how long it took for that change to happen. Now, that does not mean that average rate of change will only work when x is a time variable, seconds, minutes, hours. That's not the intention of the average rate of change calculation, and it's not a necessity. It's just an easy way to frame in your mind how to think about average rate of change, because that's how we're used to thinking about rates of change, is according to a time. So we evaluate f at 3. So we have 16 minus 3 squared. Then we evaluate f at 0, which is 16 minus 0 squared. All of that over 3. This is 7. This is 16. 7 minus 16 is negative 9 over 3. And our value of the average rate of change is negative 3. What does that tell us? Well, for each unit of x, this function changed on average negative 3 values of the dependent variable. It's not a great way to say it, but for every change in x, for every one change in x, we got a negative 3 change in the value of the function. You can see that right here. So as we go from one value to the next, the value of the function went down 9, but it took 3 units to do that, which means on average, the rate of change is negative 3. An interesting way to think about changing functions that are not linear. Linear is going to spit out the same rate of change every single time. But depending on where we do a quadratic rate of change calculation, we might end up with a slightly different result.